Good. We may as well make a start. Thanks all for joining this morning. Appreciate you taking time out of your busy schedules for 30 minutes or so. This is our second webinar we've hosted, actually. Some of you probably joined our previous one on the changing footwear standards within the industry. But this is obviously around the closed loop workwear. I'm sure you'd all be aware of who we are at SAFPRO. We are obviously a provider of branded uniform, of PPE. And the reason for hosting this webinar today, there's been a lot of interest in closed loop workwear. Queries in relation to what it is, how does it come about, why is it required within the industry, within the textile industry, how is it different from other products? And I suppose a lot of the interest came from a project we worked on with Project Plan B, who are joined with us today, Tim. And that stemmed from project we worked with Integra UK, one of our customers within the mechanical electrical sector, property maintenance, and we supplied Integra with fully circular closed loop polo shirts, preventing around 3,000 polo shirts from going into landfill annually. And we feel responsible as a supplier of workwear to raise awareness, I suppose, as to the impact that workwear does have on the environment, and share that with others within the industry, with our consumers, and go over the wastage problem there is within workwear and how partnering with Project Plan B, there certainly is a solution there to bring to the consumers. And so I suppose I'll hand over now to Tim Cross, who will be leading the webinar. We'll run through the whole process with yourselves. If you do have any questions, feel free to pop them into the chat box, and we will come to the questions at the end and go through a quick question and answer session. Brilliant. Well, over to you, Tim.
Thanks very much, Stefan. Good morning, everybody, and thank you very much for this opportunity to explain a little bit more about Project Plan B. The world of uniform is changing, and it's changing very, very rapidly. And the era of circularity, of sustainable clothing is very much upon us. And I'm going to try and explain how we have approached this and why we feel that this is a really good time to make a switch to more sustainable and more circular clothing. So I'm going to try and share my slides now. Hopefully that will give us an opportunity to see what we all see that. And so Project Plan B. I've been in the garment manufacturing business for the last 25, nearly 30 years, and we have been manufacturing clothing, a large majority of it obviously out of polyester. And we were quite happy with that. We thought our ethical standards were pretty good, so that's probably good enough. And then we realized that actually we were making a huge amount of waste. Every time we did a uniform rollout, the old uniform was either binned or burnt. There was no solution for it. And we just wondered why that was, because we knew we could make clothing out of plastic bottles. And if you can make clothing out of plastic bottles, why can't you make plastic bottles out of clothing? What were we doing to the clothing that was preventing it from turning into something that we could reuse? And we decided we'd have a really good look at it. The problem of uniform, it's not a small matter. RAP and a few other people have done some surveys on this, and they reckon that nearly 40 million workwear garments are supplied every year. I suspect it's an awful lot higher than that. I suspect that it's probably at least twice that, but we don't really know what's going on in the industry. But we do know that there's a huge amount of waste that's coming out of the back of it. What we wanted to try and understand was, if you can understand the recycling process, could you design clothing for the recycling process? Now, clearly there wasn't a recycling process for workwear and uniform. There wasn't anything out there for textile polyester. And the reason why there wasn't anything out there for textile polyester, it transpired, was because there's no clothing that is recyclable through a machine. So if you made a machine, you'd then have to change the design as well. So the design of the clothing needs to fit the recycling technology. And that seemed like an awful lot of hard work, but actually we realized that that is exactly what happens in every other recycling industry in the moment that we've got. So with plastic bottles, you've now noticed that the lids on the plastic bottles match the bottle itself. You've designed that bottle for recycling. And we needed to start doing the same thing, making clothing that could be recycled. The problem was that we didn't have a machine that could recycle it. So even if we had designed it for recycling, we didn't have a machine that could do it. So we set about building one of these machines. So this is a thermomechanical extruder. And these exist in the hard plastics world. They didn't exist in the textile world. So we had to set about trying to figure out how you could turn something that used for hard plastics into something for soft plastics. And we spent the last 5 years figuring out the design, changing loads, doing lots and lots of trials, and we've come up with this machine. Essentially what we're doing is you've got an inbuilt shredder. So the clothing goes up, and I'll show you a video of this in a few minutes time, but this clothing goes up that conveyor, drops down into the extruder, and then under heat and pressure, it is melted. It comes out as pellets at the other end, and we can process with this machine. Our year one objective is about 2,500 tons, and we expect to get up to about 10,000 tons of textile polyester by the end of the year, by the end of 2 years. The aim of this, obviously, is to offer a solution to the workwear and uniform industry, but also to the wider clothing industry as well. Polyester is in about 55% of all clothing. So here are some pictures of it in process. You've got textiles going up on the left, getting shredded, and then going through the extruder and coming out as pellets. Now, if the gods are with me, then I can try and play this. Is that there might be sound, but honestly, all you can hear is noise. So the textiles are going up there. It's being dropped down into the extruder. And there's the control board showing us everything that's going on, so we can work through it. This is uncovered at the moment, so you can see the process going on. It's going through a filter there, through another filter there, and then it hits the pelletizer, and there you go, pellets being made out of polyester clothing. They are then cooled. There's another monitor showing you what's going on. Goes through a cooler, and they then come out into a hopper, and you can see this chap is going to try and capture some in his hand. So there you go, there's some pellets. These are still quite hot, hence the fact he doesn't hold them in his hand for very long, but they have dropped in temperature down from the 260 degrees when we melted it down to something that is hopefully going to then go into this hopper there and into that bag there. And there you can see a sample batch being collected on the side. Oops. So there you go. That's our recycling machine in process, in action, and that is going to be up and running at commercial scale by the end of this year. We will continue to carry out trials over the next few months, and then hopefully by the beginning of January next year, we will be able to open this up for all level of commercial recycling, and hopefully enable people to come and have a tour and have a look around and come and see how that it's all working. So what do we need? Well, we need good feedstock, and that is the key part to this. We've got to have feedstock that we can work with. And that goes back to what I was saying earlier. You've got to design clothing that can be recycled. And what we've worked out is that if we get good feedstock, we can spin it back to yarn. So we've done lots of trials, and I can probably show more easily at the end once I'm stopped sharing, but back into wools like this, or back into yarns, we can produce pellets. So pellets such as these are made out of white yarn, and pellets that are darker. So if you do high vis, you'll end up with high vis orange coming out. we know that we're going to have a gradation in the recycling hierarchy. So what is very good will go back into yarn. What is not so good will go back into injection moldable plastic, and you can make coat hangers out of it. So there are infinite uses of it because you're getting it back to plastic. You're getting it back to a point where you can move forward. So why does it work? Why have we been able to solve this? Well, the truth is we've been able to solve this problem because we understand clothing, and an understanding of clothing means you can understand design. If you can understand design, then you can understand how you can make clothing that is recyclable. So take the polo shirts that we did for Integral. It was 100% polyester polo shirt before, it's 100% polyester polo shirt afterwards. What have we changed that it had made it so different that it could now be recycled through one of these machines? Simple fact was that if you don't design it to be recycled, it can't be recycled. The old polo shirt had nylon buttons, nylon tape, it had a nylon label, and all of those things were preventing it from being recycled. So if we changed that design so that it was made out of recyclable materials, then you solve that problem. And the same is true of just about everything else. So we started looking at school uniform. So we took a school blazer and working with a school uniform company called David Luke, we redesigned their blazer. So their standard school blazer was already 100% polyester, but was unrecyclable. All the linings, all of the trims, all of those were full of contaminant material that prevented it from being recyclable. So we changed a number of things within it, and an understanding of garment design, an understanding of what we needed to do, and an understanding of the technology enables us to change the design relatively simply to a garment that didn't cost any more, but was fully recyclable. It has no change to its look or its functionality. It still behaved in exactly the same way. But now, annually, 340,000 garments will be saved from landfill. So there is no need for those garments to be binned or burnt, and we can recycle them. And that's really important because in fundamentally changing the way you've designed a piece of clothing, you've now encouraged it to be recyclable. And you now want to make sure that it is recyclable because you've made all those changes to it. So you're going to want to make sure we get it back. So why does recycling help us as an industry? What is in it for us? Well, in that one, 340,000 garments, that was 170,000 kilos of polyester saved, which is a huge amount. If you then look at the carbon footprint of that, you go, well, what if we made garments out of virgin material? There is 5,180 kilos of CO2 for every ton of textiles. If you make garments out of recycled polyester, out of PET from clothing, that's 597 kilos. It's about 11% of the energy involved in making polyester that you can spin from by going down this route. So there's a huge carbon saving. If you're able to save 88, 89% of the carbon by taking yourself down this route, that could have a real impact on the way we make clothing. We try to look at this from a larger scale. So if we looked at it from, let's say, a large supermarket, which maybe has 150,000 members of staff, that's 1.2 million garments ordered each year to fulfill that contract. 400 tons of plastic that will be kicking around in those garments. That's 404 tons of CO2 as every garment was incinerated at the end of its life. So every time there was staff churn or damage or whatever to the garment, they were being incinerated, and all of that resource that had gone into making that garment was lost. But furthermore, if we then quantify the CO2 saved, because we can now use that pellet again, that's a further 2,240 tons of CO2 saved by going down this route. And that's a huge amount. Now, if you happen to be a large supermarket, you're already buying carbon credits. You can now reduce down your carbon credits because you've made that decision. So if you looked at it from a cost perspective, if you were buying carbon credit before, that's £156,000 saved because you decided to recycle. £388 per tonne, or 13p per garment. And that's a huge opportunity. You're now putting a price on the opportunity to save clothing from landfill. You're now actually not only achieving net zero targets, you're now starting to lower down your CO2 impact and actually save money. So this is something that became really important to us. And we did a lot of research with UAL and RAP last year to understand why carbon was a really good way of understanding the damage and the impact of clothing. If you can redesign your clothing so it's recyclable, and be that turning your polycottons into polyester or turning your cottons into 100% cotton, and making sure that they can be recycled, then there are similar savings to be had. And all of this is really going to matter. It's going to matter a huge amount over the coming few years, particularly because of European legislation, which the UK will end up adopting and matching, called EPR, Extended Producer Responsibility. And an understanding of extended producer responsibility will tell you a huge amount about the direction of travel. And fundamentally, if you don't design your clothing so that it can be recycled, you'll pay. If you use unsustainable materials into your garment, you'll pay. If you don't know where your garments are and can't clear them up afterwards, you'll pay. All of this is going to become really impactful. And we are doing lots of work with lots of very big clothing companies at the moment, trying to help them with this impact. Because one client that we are working with at the moment recognized that the cost of EPR will probably impact them to the tune of about £75 million a year. So it is going to be huge, and it is going to be problematic, and you need to get ahead of it now. Because if you're making clothing that is going to be in use either in Northern Ireland, the EU, and fundamentally it may well be in the UK by then as well, you will end up having to deal with EPR legislation. So it's going to become really, really important. Once you've made the switch to recyclable clothing, though, your costs are no higher. Your opportunity is that much greater. The carbon cost of design can be calculated, and you can end up with a saving. You've got EPR savings that are coming down the line. You've got marketing opportunities. You know, the share price of your company will go up if you're now hitting your net zero targets. And hitting those net zero targets will become really, really important. And we know that DEFRA are very interested in the workwear and uniform market. So my advice is get ahead of it and have a look and see where it is. Just to give you a bit more background on this, when we looked at, or RAP looked at the impact of clothing, the biggest opportunity is in recycled materials, recycled fibers. So if we're trying to get to the UK's net zero targets, if you look in the middle there, you've got 12% on the left-hand one and 18% on the right. They are all down to the use of recycled materials. So moving over to recycled materials is an absolute no-brainer if you're moving towards your net zero targets. Again, the opportunity here to contribution from using recycled fibers is the greatest opportunity is in recycled fibers at 12% there as well. The reason why this makes a big impact is why do recycled yarns made out of plastic bottles cost more than virgin at the moment? The main reason is simply because they have got the amount of demand for plastic bottles exceeds the supply. And when demand exceeds supply, price rises. Well, why does the demand exceed supply? Well, because we keep turning these plastic bottles, which are infinitely recyclable, into clothing. And the moment you turn it into clothing, it's not recyclable again, unless you follow our route. And the cost of those plastic bottles is going to continue to rise until we as an industry start feeding the feedstock back in. You start putting it back in to be recycled. You then increase the amount of recyclable polyester that's in the marketplace. The price will fall. We have to engage with this, because if we keep working in a linear fashion, we will expect prices to rise. So The more product that we recycle, the lower the price on everything that's going through this. The waste and recycling hierarchy in here. There's not a lot that I can really say about that and what you can see in it. Fundamentally, if we don't put product back in at the beginning, we're going to have a problem. We're going to have a problem with feedstock. So it will take a while for this to even out, but we've got to start somewhere. We've got to start creating clothing that is recyclable and pushing it back in. And the workwear and uniform side of things has absolutely got the best opportunity for us, because we know that, you know, most of the uniform, we know where it is. It's within a closed loop. And if you know that it's within a closed loop, we've got a tremendous opportunity to get that product back in and use it all over again. So making sure that you work within a closed loop system is absolutely the right way forward. I'm going to sort of finish now. The global economy is not a force of nature. It's made of a million decisions. It is designed and it can be redesigned. This is absolutely the mantra that we follow. I started the Circular Textiles Foundation off the back of this because I found that the only way we could explain why we need recycling to move to a recycling position and why we need feedstock is to explain to everybody that if you design for circularity, you stand a chance of having recyclable material. If you don't have recyclable material, your carbon footprint is going to continue to rise. So we needed to approach both things. We understood that the recyclers don't understand clothing and the clothing manufacturers don't understand recycling. So we need to be there to help. This solution, I think, is absolutely the start of a revolution in the way we make clothing. And, you know, I really hope that everybody here has now got at least some understanding of where this is going and hopefully can see some opportunity to get involved. I'm going to stop sharing and then come out and see whether there are any questions. Stefan, back to you.
Yeah, that's good. Excellent. Thanks, Tim. Did you want to run the Q&A session, Junior? Looks like we've got a few in there. So
yeah. Thanks, Tim. There are a few questions via the live chat. If you can view those.
1 moment. The first one I can see there is, where can I find more information on EPR? It's very difficult to get clear information on this. I was at the Textile Exchange conference last week, and there was a lobbying company there presenting and explaining the EU legislation. It is definitely going to be here by 2025. It will evolve as they work towards a position for 2030. There are some slides out there. I can share one which I can sort of email out to Junior and you can forward around, but it basically gives a good understanding of what's happening in this space. And it's basically saying everything is happening from 2025 onwards. What they're not clear on, unfortunately, is that they're not actually that clear as to how it will be rolled out. They've said that it will be all companies that are over 2 million turnover, I think, will be affected by it, and it will affect all clothing. They are less clear on whether it will affect home furnishings and so on, probably not in the first round. Next question, how long does it typically take to design a garment, produce it and roll it out? Exactly the same time as you'd expect for a normal production run. So I suppose 4 to 6 months, depending on the time of year. So it's not particularly time consuming. What sort of condition do the garments have to be in to be recycled? As good as we can possibly have them. The best that is unworn, but that seems kind of pointless. So I've designed it so that it can cope with a high level of contaminants that are in there, but we are still mindful of the fact that pockets could still have items in them, so they need to get checked. And we are looking at various systems to either do a pre-shred on it to try and remove all of those things, and we'll just have to see. But the better the quality, definitely has to be clean and dry. We do not want garments that have been stored outside or anything like that. They have to be kept clean and dry. But most garments, particularly garments coming out of laundries, are absolutely fine, and we can work with those without any problem at all. What are the main challenges that you've experienced through the trials you've had run so far? The hardest thing is not knowing what's in the garment, and when garments are designed to be recycled, you're absolutely fine because you know what's gone into it. Dealing with garments that are already out there, which we don't know, that's much, much harder. So we're constantly trying to understand what could be causing a problem. And it's usually because we don't know what finish has gone onto a garment or something like that, or whether there's any FR treatment that has gone into it. We can cope with most things so long as we know what they are. And the other point I would say is that solution to pollution is dilution. The reason why that makes sense is if there's a very small amount of contamination, it's absolutely fine. If there's a lot of contamination, then there's a real problem because it is not diluted enough with everything else. But the main challenges we've had really are that we don't know what's in the fabric. But if we know what's in the fabric or the fabric has been useful, then it's usually fine. Do you provide a means of collection for returned garments, and how would this work? We don't provide it. We expect the garments to be either delivered to us, but there are solutions coming down the line which will hopefully help with that. We are working in partnership with the Salvation Army, who have the site at Kettering, and we will be utilising their logistics where we can. It may be that down the line that we can utilise them to collect from various premises, or it might be that we can get a collection bin on your premise so that you can put the product into that and it can then be collected. But that really depends on the volume, and it depends on your relationship. But ideally, we want to work with uniform suppliers like SAFPRO so that they are part of that solution. Are you able to evidence data on this to individual clients? Yes, we are. If you know what you've made, we can give you the carbon costings and footprints on that. If you are able to weigh in the garments that are being collected, we can check that and confirm that when it turns up with us as to what was recycled and what the output material from that was. So yes, we can always help with those kind of things. Are there any other questions from anybody?
There's one from Sue Arrowsmith as well in the Q&A. Can you see that? Can polycotton garments be recycled?
Short answer to that is no, they can't. There are at the moment there are no systems out there to recycle polycotton garments. There is the opportunity to recycle white polycotton linen at high cotton content, low polyester content, but the polyester isn't recycled, it is burnt. So there are solutions coming for polycotton, but they could be as far as 5 to 10 years away because it is extremely complicated. And the truth is that if you were going to run a recycling system, you'd want to recycle one product. You don't want to try and recycle two. And if you are trying to recycle one and you're working with the 65-35 polycotton, then you're either going to have a highly inefficient system that's only working at 65%, or you need to try and have a system that can collect both. And then you need to be economic on a 65% and a 35%, which is going to be even harder. So I think there are significant challenges there. However, there are some real opportunities coming down the line. What I would say is the carbon footprint on those will be different, and The answer is, if you can design it to be recycled, design it to be recycled, and design it to be recycled through the lowest carbon opportunity that is available to you. If none of that is available to you, then design for the next one up and work out what you can do best with it. Is there anything?
There's one more question in the Q&A, Tim. How does the price stack up against the current market rates?
So we have costed the gate fee for recycling at the same rate that it would be for incineration. So to try and match that. So if you're paying for garments to be incinerated at the moment or destroyed, either because you need secure destruction or because you need to send them away for burning, we're trying to match it at about that price. I am sure that things will change down the line, but at the moment, we're trying to be as economic as we possibly can be with this. There's another question here. Are there any limitations to the garments that you can produce? No, not really. We think that there are opportunities in all kinds of things. So the real challenges are for garments that require a lot of elastane. And so if you look at sportswear that has got high elastane content, elastane, which is made of polyurethane, is completely unrecyclable by any technique or technology. It won't even be chemical recycling, which is coming down the line, won't even touch it either, because some people will be able to cope with it, but they won't be able to recycle it. But I was speaking to one of the team at Lycra last week, and they are developing polyester-based elastanes that will be able to work as a really good compromise to using Lycras. So again, moving back towards monofiber, but you will have the opportunity to work with that. We can work with all kinds of different fabrics at the moment. Some really good polyesters out there that we can work with that produce a fabulous mechanical stretch that you wouldn't even know that there was no elastane in it, and there is really good stretch and recovery in those. Knit structure can make a massive difference, and we can, have shown that there's some really good opportunities there as well. So I don't feel that there's a huge amount of limitation to it, but inevitably it requires careful thought to make sure that the product you're developing is suitable for the use that you've got. Is there a limit to the amount of times a garment to go through this process? That's a really common question, and a lot of people have said, well, you can only recycle polyester once, never, all kinds of different things. The truth is that polyester is a long chain polymer. You can always improve it, and you're never going to know whether the garment that you're wearing has been recycled once, twice, 3 times, 4 times. You just don't know. The same with the plastic bottle. When you drink from a water bottle that you bought at a petrol station, it's made with recycled plastics. Do you know how many times that has been recycled before? Do you care? No, you don't, because as long as it functions, you're absolutely fine. So whenever we are looking at this, the chance of a uniform rollout all happening on the same day, and then all of those garments being collected on the same day, and then being recycled into the same uniform that is used and then recycled again on the same day, is absolutely minuscule. It's never going to happen. The much more likely scenario is that garments come in dribs and drabs. They get blended in with other products. Some of it had been recycled once, some of it recycled never, some recycled 10 times, and round it goes. And then it goes off to the yarn spinner. The yarn spinner will then improve it, add whatever he needs to make the quality of yarn that he sells, and then you'll buy that yarn and you won't know any more as to whether it was recycled once, twice, or 1,000 times. It can always be improved. Anything else? Or anything I've missed along the way?
There was a question previously did allude to around the comfort of polycotton garments as opposed to 100% polyester.
Yeah.
You could expand on that.
So what do I think on that one? The reason why we added polyester to cotton was to make it last longer, and because it held its color better and it had better dimensional stability. the reason why we moved away from 100% polyester was because we felt that it was sticky, sweaty, and slimy. Well, both of those things have been fixed by technology now. So we've got antimicrobial, water-moving yarns that are much, much, much more effective and can be worn all day without anybody feeling sweaty. If you move the moisture away from the surface and evaporate it, the wearer cools down far better than they would with a polycotton garment. And if you make sure that you're using quality yarns that are comfortable, then there's absolutely no reason why you can't move to monofiber polyester. Alternatively, move to monofiber cotton, which can also be recycled. And if you design it to be recycled, you can go toward that. But you then have the issues of you might have greater warmth and perceived comfort, but you will then lose out on dimensional stability and color fastness. So I would always advocate using a high quality moisture moving yarn that has permanent inherent wickable capabilities, and they are the most appropriate yarn to use.
Good, thank you, Tim. I think that wraps up the session. Don't think there's any more questions. We will be sharing a recording of this webinar and some links to the EPR that we mentioned earlier. So yeah, thank you very much for attending, everyone. Your account manager is available for any further questions. Thank you. Anything else to add, Tim?
Thanks very much indeed.
Good. Thank you all.